Please let me know if you can see my screen. Okay, thank you. Okay, thank you. Let's start now. So yesterday, last class, we told that I told you that we'll start a new chapter, which is measurement of resistance. So now, from today onwards, we'll read this one, measurement of resistance. So all of you know that the resistance is a very important component, circuit component of any electronic circuit, and the values of the resistance should be measured. And how we can measure the value of the resistance, that is the main things in this class, and maybe coming couple of classes we will be discussing. So if we see that the measurement of resistance, you have to keep in mind not a single instrument can measure all types of resistance. All types of resistance, I mean that very low resistance, medium resistance, and very high resistance. So a single type of instrument cannot measure all the full range. So you need three different types of instrument for measuring the resistance. So one type of resistance may be for measurement of low resistance, another one may be medium resistance, another one is high resistance. So before prior to your measurement, you need to know that a typical range of of your resistance which you want to measure. Now let's discuss what do you mean by, or what I mean by the low resistance, what I mean by the medium resistance, and what I mean by the high resistance. So low resistance means that the resistance in the order less than 1 ohm. Okay. So the resistance less than 1 ohm may be classified as low resistance. So in practice, such resistance can be found in copper wire, winding armatures, okay, contact resistance, switch resistance, etc. So this is a very low resistance. That means when the resistance become less than 1 ohm, it is a very low resistance, and those resistance are generally that resistance at the contact point, or resistance of small armature windings. Okay, and then ampere shunt, we have read that, contacts of various contacts, and switches. Now the medium resistance, it is very easy to measure. So we classify the medium resistance between 1 ohm to 100 kilo ohm. So if a resistance is in between 1 ohm to 100 kilo ohm, so that resistance may be classified as a medium resistance. And most of the electrical apparatus used in practice are consist of medium resistance, like electronic circuit, carbon resistance, metal film resistance, and whatever resistance, and also whatever resistance you use in lab. That is generally, although you use mega ohm very frequently, but most of the resistance are in between the 1 ohm to 100 kilo ohm. Now, what do you mean by the high resistance? A resistance higher than the 100 kilo ohm are classified as high resistance. Okay, so which are the more than 100 kilo ohm, that means 1000 ohm or something, mega ohm, those things are known as the high resistance. So high resistance are a circuit component when you see that the isolation is required. So suppose a electric line is there and you need to make one isolation. So then isolation means disconnection. So disconnection means you need to have a very high resistance in between two, then the isolation will occur. And if the resistance is less, then the isolation will not work. So you need to measure those type of resistance. Isolation resistance is the main matter when you say that the more than 100 kilo ohm or mega ohm. So insulation resistance is electrical equipment of different equipment, or in a circuit, is a kind of um, example of high resistance. Now, if we move further, so first, what I said that the measurement of medium resistance is most easy and popular. So, if we want to measure the medium resistance, what are the different types of measurement we could do? We could do the ohm meter method, we could do the volt ampere method, we could do the substitution method, or we could do the Wheatstone bridge method. Ohm meter among these four methods, so ohm meter methods, voltmeter, ammeter methods, VI method we usually say, substitution method, Wheatstone bridge method. So among the four methods, ohm meter methods is the most popular one or most easier one, and you can see that the ohm meters method can also be divided into two ways. One is series and another is shunt. So series ohm meter method and shunt ohm meter method. So this is the whole classification for medium resistance measurement. Now if you proceed, so let's see this type of circuit arrangement. So you see that there is one meter on the left hand side, which may be the PMMC meter. So you have read that PMMC meter, and that PMMC meter can be used for measurement of resistance. And if you see that the PMC meter, it has a pointer, it has a permanent magnet, it has a moving coil, everything, and this coil will take will be arranged with some resistance. For example, so you see that this PMC meter, maybe its resistance is Rm, that is a meter resistance. One thing you note, at the left hand side infinity is written and the right hand side 0 is written. Okay, that means that is the value of the resistance. If the value of the resistance is 0, the pointer will be on the right hand side. If the value of the resistance is infinity, it will be on the left hand side extreme. So why I emphasizing this? Because this type of meter is just reverse than whatever you use in voltmeter or ammeter. In voltmeter ammeter, generally it starts from 0 and it goes right hand side to increase. But here it is opposite. Here it is starts from 0, but it goes left hand side to increase. So that you should note it. Now you see there are a few resistance. For example, there are resistance which is R1. First I say, so R1, you see that R1 is the resistance which limits the current and which enters into the PMMC meter. So R1 we can call it is a current limiting resistance. So R1 is a current limiting resistance. Then R2, if you see the R2, R2 is generally used for adjustment of 0. So because if you see the R2, it is a kind of shunt. So R2 is a zero adjusting resistance. Now you see the battery EMF E, that should be present inside the ohm meter. So that is the internal battery, it should present because some current should pass, and it will not be a passive type of instrument, it will be active instrument. Now, if you see that the point A and B, that is actually available to user. Left hand side of the point A and B, those are internal structure of the meter, and the right hand A and B point will be available to the user, and user will keep a resistance of unknown to the point A and B, and so that the meter deflection will happen, and from the meter deflection you can know the value of the resistance. Now suppose if you don't have any resistance Rx, that means that the infinite resistance is connected. So then the meter should deflect on the left hand extremum and it should show the infinity value. Now suppose when Rx is 0, that means you short it, that means you connect with a wire the terminal A and B. Then what will happen? The pointer will be on the extreme right hand side and it should give you the 0 value. Okay, so whenever you start such type of measurement, what we generally do, these two probe is connected together, and if we see that the meter comes to 0 value, that means the meter is working. And if it is keep open, it should go to the extreme left to show the infinity value. So if this infinity and 0 is working, that we feel that meter is working, and we start keep on taking readings. Now, another things I used to emphasize, which is not inside the slide and which is not written in any book, whenever you do some experiment, and whenever I say that what is the resistance, what you do, you generally directly, without taking out the resistance from the circuit or without disconnecting the circuit, isolating the resistance from the circuit, you just put the two probe of your meter on the resistance and it gives some Beard value. Why it gives some Beard value? Some absurd value. Okay, suppose you want to you expect that your meter will be say 10 kilo ohm, it might give 450 ohm or many other absurd value. Why it happens so? All of you must have noticed this during the lab of basic lab 101 and analog lab. I don't know whether it was conducted or not due to COVID. Whatever be the case, so if you immediately put your two probes into the to resistance without disconnecting it from the circuit or without isolating it from the circuit, what will happen? That resistance you want to measure the resistance of that, but other resistance whatever available in the circuit or whatever in the circuit will also connected. So you will measure the equivalent resistance of all the resistance on these two terminals. That is what you get some weird value. So whenever you want to measure a resistance, you take it out from the circuit and then use the two sides of the resistance and the ohm meter to measure it. Okay. So otherwise you will get some absolute value. It is not absolute value. It is actually the value consists of all combination of circuit resistance what is available in the circuit. If you don't take the resistance out, so that you should keep in mind while you do the lab experiments or practical. Okay, so take away from this slide is that for the series ohm meter we have a meter which is called the PMMC instrument, a simple PMMC instrument, and its scale as I discussed, and it has two resistors are connected, R1 and R2. R1 is called the current limiting resistance, R2 is called the zero adjusting resistance. There will be one EMF, E will be connected, and there are two terminals A and B on which the unknown resistance which you want to measure should be inserted. Once you insert this meter will deflect, and you can meter reading can be calibrated so that you can measure the resistance value. Let's see if any question or anything. Chat box. Okay, no question. So hope all of you are getting it. Let's proceed. Now, if you see that, so these things I wrote that the series, this is a series type of ohm meter. It consists of basically a DC PMMC instrument, and there is a PMMC instrument or PMMC ammeter, whatever, and connected with a variable resistance R2, which is called the this one R2. You note it, which is called the zero adjusting resistance, and then a series resistance R1 is connected, which is called the current limiting resistance, and a battery is connected with it, and the entire arrangement is connected inside a box, and two pair of terminals A and B will come out, and unknown resistance of Rx should be measured by connecting the two terminal of it in the 2 point A and B. What I said before actual readings are taken, the terminals A, B must be sorted together. Once it is sorted, that means a resistance of 0 ohm is Rx is 0, and maximum current flows through the meter. So the shunt resistance R2 is adjusted so that the meter deflects corresponding to its right most full scale deflection position. That means extreme uh, when the shunt resistance R2 is adjusted so that the meter deflects corresponding to its right most full scale deflection. So the full scale deflection of this pointer is marked as 0. So actually this R2 is just 1 minute. This R2 you can see this R2 is for zero adjusting resistance. Now you can see how it can adjust the 0. So suppose there is no resistance in between A and B. No resistance, I mean that the point A and B are sorted. Once the point A and B are sorted, what will happen? No current will flow through the A and, a current will flow through the A and B, and what will happen? The meters. Now you have to adjust. Now you have to adjust R2 in such a way. So R2 is a shunt. So R2 is such a way that the division between the current I1 and I2 will happen. Okay, and once the division between the current I1 and I2 will happen, it should come at the 0 position. Okay, and once AB is open, there is no current flowing through it, so the meter remains undeflected, so it should mark as a infinity. That is the case. Let's proceed. So when the terminal A and B are kept open, Rx is infinity, no current flows through it, and the meter and the pointer corresponding to leftmost zero current position will be on the scale, and you have to mark it with the infinity. So thus the meter will read infinity resistance as zero current is coming inside the meter, and the full scale position, it will be marked as a 0. So we marked the 0 at the extreme right, and we marked the infinity at the extreme left. So it is contradiction to the convention we use for the standard ammeter and voltmeter, where the 0 comes on the left hand side and most increasing terms will come on the right hand side. So it is just opposite. You have to take care of this in your mind. Now there is some problem. For example, there is a battery problem. Okay, when you see the battery problem, so this battery E, whenever we insert, so this could be with the time the EMF of E will degrade definitely. So what will happen, so if suppose with the time the current E is getting degrade, so then what will happen as the current with the time they will get degrade. So the current entering into the PMC instrument will be changed. That means with the time it will decrease. So your calibration will change. So once you are calibrated correctly with full E, what will happen when the E decreases? The I2 will be less. The meter will give you the less reading, and that will be not be exactly the value of the R, unknown R. So what you have to do before you start measuring, you have to do that you short the circuit A and B, and you see that if it is marking at 0 or not. If it is, when it will mark 0, that means a full scale current will go inside it. If it will not mark 0, that means full scale current will not go inside it. So if it is not marking 0, so that means your calibration has changed. That means your EMF of E has changed. So then what you have to do, R2 is a variable resistance. You have to change the variable resistance so that the specific current will pass through it and it goes to the 0 position. The pointer goes to the 0 position. So the main takeaway is that before starting the readings, you should see that when you sort this, whether the pointer is showing at the 0 point or not. If it is not showing at the 0 point, what you have to do, you have to vary the resistance R2 such that it shows the 0 point. And once you vary the resistance R2, and so that it shows the 0 point when ABR short circuited, and when it shows the 0 point, that means your meter is somewhat calibrated, and then you can start taking the measurement of the unknown resistance. That's all. That is why R2 is called the zero setting resistance. Okay, now tell me if you understand everything. Let's see if there is anything in the chat box. Okay, fine. So no query. So now tomorrow whether we'll do class or not, that is another. Tomorrow is holiday, but if you agree, we can. There will be one class. So let me write tomorrow. Do you like to have a class? So tomorrow, if you want, I can conduct a class at the same time. And although it is holiday, but it is up to you. If you say that no, in holiday you are not ready, that then I have to drop the plan. Tell me, what do you want? Quickly. No response. I don't know whether you people are hearing or not. Okay. So let's see other students also. You please tell. Next thing is that you please think and tell. I am waiting. Next thing is that the Viva exam of mid sem. When do you want Viva exam of mid-sem? Uh, when do you want to have
Maybe
Viva exam?
sir, in
Tell
case
me,
sir, if
please.
you
Huh?
sir, in case if we want the Viva, sir, we can conduct it after Diwali holidays or maybe in next weekend, sir, if possible. Not in this weekend, next weekend, if in case you want, sir. Hello.
You want means I have to do it. Yes.
See,
This weekend is
we
not
know
possible. I am thinking about this weekend.
next
Maybe
weekend, sir.
Sunday or something.
Uh,
Because you see, it will take a full day and even more than one
no,
day.
no,
Because
sir. It will take, sir. It will
doing
take
Viva
three
for
days. It takes 3 days, sir. At least it takes 3 days, sir. On the
why?
if on the
Why 3 days?
takes 2 days. I mean, 2 days at least, sir. Yes, sir. In the past, sir, the Viva has been conducted, sir. It does take a minimum of 2 days, sir. Minimum of 2 days. Solve sir has conducted, sir, face-to-face Viva involving 10 minutes and in
Okay.
stress for
Okay.
that's why, sir.
So
So
when
if
do you want then?
sir, in next weekend's holidays we want it, sir. Not in this Sunday, Saturday, but
When is
next
the
coming
holiday? Next weekend?
next weekend. One second, sir. I will just check. 20, this is what's 23, 24, 30 and 31st, sir. 30 and 31st, sir. We want, sir.
30 and 31st you want.
Yes, sir.
1 week you want.
Yes, sir.
Okay,
We,
let
sir.
me think. I was
Yes, sir.
thinking about 23, 24. So let me think.
Yeah. Oh, okay, sir.
Because already you have given the exam, na? It will be on the syllabus of mid-sem. So why do
Yeah.
you need more time? Already you have
Just,
appeared the exam.
just to go once again, sir. That's why, sir, because it was 10 days of in mid-sem holidays. It was bit of more relaxation. So that's why, sir. If possible, sir. We are not just demanding, it's just if possible, sir. 1 week, sir. Just if possible, sir. If
Okay,
possible.
let me decide. Okay, so now
Yes,
let's
sir.
come back to our
Okay, sir.
study. So
Yes,
maybe
thank
then
you, sir.
tomorrow we will be having a class. Okay, tomorrow
Yes,
we
sir.
will be
Yes, sir.
having a class.
Yes, sir. No
Mm,
problem, sir.
okay,
The
fine.
class. Yes.
Mm. Okay, now let's come to this series meter again. So what we said that the zero setting resistance. For zero setting resistance, what we have to do, Rx will be 0. So you see this figure again. So you can draw it on your notebook also. This figure we will be referring. Okay, so we can copy this also and paste it there so that for ready reference. Okay, now let's see. So you see that for zero setting, Rx, that means unknown resistance, should be 0, and Rm, that means the resistance of the meter of the basic of PMMC meter coil will be the Rm. So what will be the equivalent resistance? So R equivalent will be that Rm and R2 will be in parallel. You see the figure, Rm and R2 will be in parallel, and then it will be series with the R1. So what will be the equivalent resistance? Equivalent resistance will be R1 plus R2 and Rm in parallel. That means R equivalent will be equals to R1 plus R2 Rm by R2 plus Rm. What will be the total current? Total current I1 will be the I2 plus Im. So total current will be E by R equivalent. E is the EMF. So E by R equivalent when Rx is set as 0. So there is no Rx. So thus the current I2 can be adjusted. You see from here the current I2. So I1 will be equals to I2 by plus Im. What is I1? I1 is the E by RQ. So the current I2 can be adjusted by varying the R2. If you vary the R2, that then the R equivalent will change. If R equivalent will change, this I1 will change, and you can R equivalent is change, you can vary you can adjust by varying the R2, the current Im, so that the meter current I can be held calibrated when the main current I1 changes due to drop in the battery. That's what I mean to say. So when the battery drops or drains, the current I1 will be changing. So once the current I1 will be changing, you can change the value R2 so that the meter current IM can be held at the calibrated value, same value, and the main current I1 changes due to drop in the battery of the EMF. So in by doing this, or by changing this R2, we can calibrate it before start measurement, and the adverse effect of degrading EMF with the time can be avoided. Okay, this is one part. Next is, let's see the full analysis when there is some uh, Rx is some present or Rx is 0. Both the cases we will see. Now let's see whatever I was telling, that the meter current Im is the full scale deflection. That means full scale deflection current IFSD when Rx is 0. Meter ohm, meter resistance is Rm ohm. Ohm meter battery voltage is E. So you also see that earlier, maybe analog multimeter, if you see, maybe you have not seen that you have to put battery. Now also in our multimeter we have to put battery. So ohm meter battery voltage is E. So value of unknown resistance at half scale deflection when the pointer is at the middle of the scale. Okay. So now with the terminal, if we sort AB terminals, Rx will be 0. Okay. So what we need to know that the unknown resistance of half scale deflection. So now let's start. When the terminal AB is sorted, Rx will be equals to 0. So then meter carries the maximum current. Current will be maximum flowing through the meter, and that will be I1 max, which will be E by Ri, where Ri is the internal resistance of the ohm meter. So internal resistance of the ohm meter. So this one is better. Okay, internal resistance of the ohm meter, which is internal resistance of the ohm meter, which is R1 plus R2 Rm by R2 plus Rm. R1 and R2 Rm in parallel. That is the internal resistance, because if we see from the point AB, the full all the resistance combination will be the effect of the internal resistance. Now for the half scale deflection, what will happen? So Rx, that means what is connected along AB. Let's say Rx will be equals to half scale deflection, Rx will be equals to Rh. That means let's assume if we keep the resistance Rh, the deflection of the meter will be half scale. So in such a cases, Rx will be equals to Rh and Ih will be equals to I1 max by 2. So that will be IH will be equals to E by Ri plus Rh, E by Ri plus Rh, where Ri is the combination of R1 and R2. So if you see that the E by Ri plus Rh will be equals to I max by 2. So if you note it, so E by 2 Ri. So E will cancel out. So Ri will be equals to Rh. Okay. That means that the combination of internal resistance, if that is equals to Rh, you will get the half scale deflection. So in such a cases, IH will be E by 2RH and RH will be equals to Ri, that will be equals to R1 plus R2 Rm by R2 plus Rm. So you know that, so if I ask that what will be the value of the resistance to get the half scale deflection, you can easily calculate and determine the value of the resistance to get the half scale deflection is Rh, which will be equals to R1 plus R2 Rm by R2 plus Rm. So when the internal equivalent resistance will be same as the external or unknown resistance, then you will get the half scale deflection. This is the takeaway. So the takeaway is, when you will get the half scale deflection, you will get the half scale deflection when the internal, that means the internal resistance of the meter will be same as the unknown resistance, unknown external resistance, then you will get the half scale deflection. So if you don't know the internal resistance equivalent, so you can change your unknown resistance slowly, so that half scale deflection you will get, and then that will be the internal resistance. That way you also can back calculate. Okay. Now let's come to the series ohm meter, whatever we are studying. Like this, we can see. Okay. So now if you see IH will be equals to IFSD. So if the half scale will be equals to IFSD, so then I1 will be equals to 2H1, that will be 2 into E by 2H equals to E by RH. And also IM RM, that is the IM is the current flowing through PMMC. IM RM will be equals to I2R2 and I2 will be equals to I1 by RM. So at full scale deflection, if it means full scale deflection, RM will be equals to R2 into R2 I2, that means R2 into I1 minus RM, that will be equals to R2 into F by RH minus IFSD. So thus R2 can be calculated, you see R2 can be calculated IFSD RM RH by E minus IFSD RH. So R2, which may be unknown, can be calculated by knowing the meter full scale deflection current IFSD, knowing the meter resistance RM, knowing the RH, what will be the half scale deflection resistance, and knowing the value of the EMF R2 can be calculated. Again, we know that the RH will be equals to R1 plus this, and that can be substituted to know that R1 will be equals to, so how to calculate R1? R1 will be equals to RH minus IFSD RM RH by E. So this is the derivation what we are showing, that if how to know that R1 and R2. So I said that the internal resistance can be known by putting the changing variable unknown resistance, and when you get the full scale deflection, that will be the same as the combination of internal resistance. Now combination is fine. Now if I say that what will be the value of R1 R2, how do you calculate? So for that you need to know the EMF value E, that can be calculated, that can be known because you are supplying battery from outside. And if you know that the meter resistance RM, then you can easily calculate the value of R2, which will be the IFSD. That is also meter parameter and may be known. So meter parameter, that means full scale deflection current I. Then RM is the meter resistance, and then RH. RH will be the your half scale deflection, and then E, if we know. So by combination of this you can calculate R2, and also by knowing the combination, knowing the values of E, that means EMF, knowing the values of full scale deflection current, knowing the values of meter resistance, knowing the value of half scale deflection current, you can calculate the R1 and R2. So if R1 and R2 is not supplied, that means what will be the internal two resistance? One is the zero setting resistance, another is the current limiting resistance. If not given, you can know it by knowing the half scale deflection resistance and the meter resistance and the full scale deflection current, that is possible to know. Okay. So now let's proceed to the next slide. Again, if we do on other manipulations, we know that the equivalent resistance is R1 plus R2 RM by R2 plus R1. We know I1 will be equals to E by Ri plus Rx. We know the meter current will be this, and with terminal AB shorted, we know the IFSD equals to E by Ri R2 by Rm, and using all those expression, we can determine the Im by IFSD. That means that, so Im by meter current by full scale deflection is Ri by Ri plus Rx into IFSD. Okay. So if we know the internal combination of resistance Ri and equivalent resistance, and if we know the unknown resistance Rx, and if you know the IFSD full scale current, what is the current flowing for that particular resistance at the point AB, that is Im, that can also be known. This is a very simple manipulations with the simple algebraic equations and substitution, and this can be known. So there are 2-3 things or we prove. First one is half scale deflection resistance RH, what will be the expression of it, that we prove. Then next is, how do we know that the R1 and R2 combination, what is the value? For that we need to know the IFSD and RM and RH half scale resistance, subscale deflection resistance. And if we know that, R1 and R2 can be known. Now, what is the current flowing at any point of time? Meter Im is known. That can be known if we know the Ri, which is the combination of resistance, and that can be easily known, and IFSD and unknown resistance Rx. If we know those things, we could come to know the Im, or the current flowing through the meter. Now, if you see how this meter looks like, this is analog multimeter. In lab we have it, but generally nowadays you people use the digital thing. So in digital PMS instrument is not there, but if you see the analog multimeter, which is very popular, which was very popular, and it will look like also this digital multimeter. And if you see that the dial thing, it has the different DC voltage, DC milliampere, and ohm. Ohm means when your pointer will be at the ohm, it will act as a resistance measuring device. And if you see that the left hand side, it is written as infinity, then 2K, 1K, 500, 200, 100, 50, 30, 20, 10, 5, 2, 1, 0. So if you see that the scale are not uh, equally divided, so whenever it is going towards the left, it is more cramped or most congested, and then whenever it is coming towards right, which is 0, it is more sparse. That is the scale of it. And to measure, you have to prior knowledge that which range this ammeter will be, which range this ohm meter will be working, and based on that you have to select the pointer in that range. For example, if it is 10K, you have to select the pointer at 10K. If it is 1K, you have to select the pointer at 1K, like that. And if you can select that selection, that means the left hand side it is shown selecting the resistance. Okay, resistance, extra resistance apart from R1, R2, by selecting the extra resistance, which may be R3, R4, R5, R6, R7. And if you select that, the range of the meter will be changed. And by after changing it, if you employ this Rx, which is unknown resistance, the meter will be deflected, and you have to read it properly because the meter scale is not uniform. And once you read it properly, and first thing is that you have to make the uh, slider in such a way that it gives the inside uh, pointer deflection inside the scale. So for that you have to choose whether your ohm is resistance is either 10K multiplication or 1K or in the range of 100 or something. And after you choose, that means after you slide your resistance in that particular point, what you do, your meter will be deflected for unknown resistance, and that deflection will be observed. And as the scale is not uniform, you have to take proper precaution to read the scale. And once you read the scale, you know the value of the unknown resistance. So this is all about it, that multi-range series ohm meter, and it was very popular at some point of time because, and it uses the PMC instrument and whatever the combination of a few resistance and the EMF as shown in the figure. So now tell me, this is complete series ohm meter. If you have any query, it is complete exhaustively. So if you have any query, please tell me now. Okay, it seems you have understood because it is very simple also. There is only a few algebraic equation to manipulate, and this Ohm's law, VI laws, all the things. But it is very useful also to measure the different ranges of resistance and in the same instrument using PMMC and all. Okay, so that's all. Very good. All of you attend the classes. So now, what I feel that your next class will be tomorrow. Tomorrow 9 a.m. Is that fine?
Yes, sir. Yes, sir. No problem, sir.
Okay. So again, we will meet at tomorrow 9 a.m. like that, and 1 hour maybe we'll discuss about the other types of ohm meter. So this way we will proceed. So you see this syllabus is a little bit more, but and the subject is easy and kind of little bit elaborative or descriptive. but it is very useful in industry. Sometimes you may feel bored because of this illustration and elaboration, but you keep on reading because this will be very much helpful if any engineers works in industry, not in software. It will be extremely helpful, and without sensor and this thing, nobody can work in industry. Software you can work, but departmental thing, it will be difficult, because ultimately the thing comes with this sensor processing and control and taking proper judgment and decision. So how the sensor works, that is important to know. Okay, so Jain Shailesh is saying, sir, can you tell us exactly whether Viva will be conducted 23rd, 24th, or 30th, 31, so that we can prepare accordingly? Okay, you keep on taking preparation. So maybe the way I am thinking, that it can be divided into two weekends, because of this large number of students. So maybe both the weekends I can take, if you say, or maybe I can shift it to one weekend, or maybe Friday second half, then Saturday, like that. Okay. So tomorrow I'll tell you the exact thing. Okay. Is that fine? Silas? Okay. Okay, then thank you all of you. You might be having next classes. So let's stop here. Tomorrow again we will be discussing and about the ohm meter, and we will be proceeding. Okay. Thank you. Have a nice day. Bye.